Welcome to the Construction Disruption Podcast, where we uncover the future of design, building, and remodeling.
I'm Todd Miller of Visay Industries, manufacturer of specialty metal roofing and other building materials. Today, my co-host is Ethan Young. How are you today, Ethan?
I'm doing pretty good, Todd. How about you?
I'm doing real well also. So I heard an interesting statistic the other day. I heard that the average dog barks 273 times a day.
Wow. Okay.
Of course, that is just a rough estimate.
Oh, geez. Okay.
Okay. I don't know if I've told that before or not. I hope I haven't. Anyway, it's an oldie but a goodie, so it's classified as an oldie but a goodie if I have told it. Well, let's go ahead and get things rolling here with this episode of Construction Disruption. Today's guest is going to talk to us about something that I think is just being talked about increasingly in the world of architecture, engineering, and construction. And I think sometimes it's talked about a whole lot more than it's understood, and that is carbon capture, helping to reduce the amount of CO2 in the atmosphere by capturing it in a non-damaging way. Increasingly, we're seeing some products out there that are said to reduce smog and CO2, and today we're going to learn about that from our special guest, Tim Sperry. Tim is the founder of Carbon Limit and also of Smog Armor. Tim, welcome to the show today.
Thanks for having me on. Great to be here.
Well, we're anxious to learn and glad to have you here today. So I think you're an interesting guy in that you don't really have a degree or formal background in chemistry, yet you're on this leading edge technology. Love to hear a little bit about yourself and your background and what brought you to where you are today.
Sure. So, you're absolutely right. And I will say and preface it with this, half of my family are collegiate level educators and the other half are inventors and entrepreneurs. A majority of them are self-taught and have invented some pretty incredible things from capacitors and gyroscopes and other things for Apollo spaceship and International Space Station to the equipment that makes some classified military equipment and weaponry. And I will also say this, I'm an entrepreneur at heart. Although I did go to college, found the path of material science, and midway through, and I even took a zoology course and kind of, went on the path of material science because I've always been an inventor. And then made a U-turn when I saw how effectively segregated you had your science and business. You're almost on, in most universities, it just seems to be they're on separate sides of the universe and separate sides of campus. So I didn't really want to go and live in a lab nor create notches on the belt for how many publications and how many patents that I could create. So I took the path of Google Scholar. You guys familiar with Google Scholar?
Yeah, definitely.
I am not. You're going to have to help me out.
Yeah, most people aren't. So if you Google Scholar, you don't have to just do it that way, but you'll get a new search box and it looks like a regular Google search page. And it'll say Google Scholar above the search box. Now, every time you plug something in there for a search, it actually gives you all of the relative and related publications that have been created globally. Different scientists, different universities. It's a mine. It's a gold mine of just incredible technologies, tests, different materials. It's really pretty awesome. I geek out on it quite a bit. But you could go down Google Scholar, spend your 10,000 hours there, and you would become an absolute master at whatever it is that you want to do. If you're studying, negative emission technologies via inorganic materials, as I did, getting into negative emission technologies. And then to your point of carbon capture, I love to go down the path of carbon capture, utilization, and storage, CCUS. So I pretty much went that pathway to get there. And it's been a really incredible journey. And I think I went down that path a little bit before it became so popular in the media and such a big deal. It's always been something that has been driven from my personal passion to want to solve air pollution, as I lost family members due to air polluted deaths, unfortunately, before their times. And I just recently had a child, and I'd love for her to enjoy the world the way we all have been able to do so. And also thrive in a healthy place that supports her. So my driving passion and my reasons why.
Very interesting. And that's fascinating. I mean, I love it when an entrepreneur, is driven by their passions. I think sometimes entrepreneurs are driven by the field that they ended up in, and suddenly they thought, okay, I'll just stay in this field. But I love that. And I need to check out Google Scholar for sure. And just so our audience knows, and I forgot to mention this earlier, we are doing challenge words this episode. And I think in the future, I may use Google Scholar to find my challenge words. But anyway, each of us on the show has been given a word by one of the others that we've been challenged to work into the conversation. So you, the audience, can be listening to see what those are. Maybe you already heard one or two. I don't know. But at the end, we'll tell you whether we were successful or not at working in our challenge words. So, well, let's just, for our audience, start at ground zero. I mean, tell us some of the basics. Why is CO2 capture important? What is the overall goal of what you're doing? And I love that you're driven partly by this little baby you have at home. So that's exciting also.
Absolutely. Yeah, no, thanks so much for that. As we really look at the world today, and we're emitting about 50 billion tons of CO2, which is a pretty big number, just as we're developing countries and as we're increasing population, I think it's a challenge unless we get to absolute net zero, which today we effectively could never do that and get off hydrocarbons as the way the world is currently set up. It's going to take some time. So as we're continuing to emit more and more CO2, it's not actually getting better. It's getting worse from increased extreme heat, extreme weather events. We've broken some really bad records this year. We've been above 1.5 degrees Celsius of warming for over 18 months. Not a great place to be, because that's what we were trying to refrain from doing up till 2100. And the real consensus is now, in order for us to really help the planet, to help do things about the climate crisis, we need to remove CO2. And removing CO2 is a big challenge. There's a lot of novel technologies out there today, but they're able to do this much, and we need a lot more. So it's really important that this is getting a lot of attention in all different circles, as you mentioned in the beginning. And really the idea for removing carbon is, how can we take carbon that's already in the atmosphere and then put it into a solid format where it can't re-emit itself into the atmosphere, whether that's capturing it and then utilizing it in some form or fashion where it won't re-emit, or make it into a supercritical liquid state and injecting it down a class 6 well, which is a mouthful and not the easiest thing to do either. Not a lot of class 6 wells and companies that can do that yet. So really the idea is, how can we more effectively capture and remove some of the carbon that we've already put out there? And what are those technologies, and how can we get them to scale?
Very good. So I know that originally, as you went down this path, you were using paint and coatings to capture carbon, capture CO2, and now you've moved on to concrete. I assume the technology between the two is kind of similar. I mean, which is more effective? Tell us a little bit about the difference between those two different paths.
Yeah, I mean, even though on the surface they may look similar, they're 100% different.
Okay.
You have coating that has physical and chemical absorption capability of CO2, so it's bonding the CO2 molecules in and around and on the surface and in the matrix of whatever you have there from a paint or a coating. But it's not utilized. The CO2 molecules still stay intact, and if you were to heat that surface up enough, it would start releasing those. Generally, I don't think we're going to get to a point of heating it up enough unless it's on fire or it's put into some extreme heat situation where it would release all of that CO2. But the difference with that and what we're doing at Carbon Limit with our CaptureCrete technology, which is a CO2 capturing concrete, is when the CO2 is absorbed similarly to how it is on the coating, it's actually then interacting with they call them hydration products in the concrete. So the cement and the other materials in the concrete, and it's transforming, and it's actually a chemical reaction that turns the CO2 molecule into a solid mineral. So it's changing its chemistry and making it into a solid mineral where that will stay in solid mineral form unless you heat it above 550 degrees Celsius, which is quite a high temperature.
So I'm curious, how does the amount of through your process and what you're doing, how does the amount of CO2 or carbon you can capture compare to the amount of CO2 made in the production of concrete?
So that depends. If you look at traditional concrete and you look at these new concretes, and I'm sure you guys have seen and heard and had some experience there. Original Portland cement was generally mixed with sand, gravel, air, and water to create concrete. Today, it's more limestone-based cements, natural pozzolan-based cements, fly ash and slag that are actually reducing some of the carbon in there already. And our product just further makes it more sustainable. From a percentage basis, it's hard to say. We can capture X number of kilograms of CO2 per cubic yard, and that number can really go on a sliding scale. So we could, in effect, maybe capture an additional couple of percent, 10, 20% of what was made in that original carbon event when you're making the cement, because that's the majority of that carbon footprint comes from. It's just really dependent on the type of concrete, the use case, the compressive strength, and if it's a road versus a building, if it's a concrete block, which is much more porous. So there's not one clear answer. It just depends on the type of concrete and the use case there. But it captures a good amount of CO2 compared to concrete that's capturing a very limited amount of CO2, because concrete naturally does absorb CO2. But once it absorbs it and it gets in and on that surface and creates more impenetrable barrier, it's kind of like a steak. If you're grilling on the outside and you sear it out, you're not going to get too much on the inside there from a sear level. You're gonna cook it, but it's not going to go all the way through.
Gotcha. Well, I think that's interesting. I think one thing, I think a lot of folks, when you think of concrete, and you think of your driveway, and people don't realize how many buildings are simply concrete based in their structure now as well. So that's really kind of what you're going after, I assume, is more that, where it's being used to actually build the building, maybe not necessarily someone's driveway in the front of their house. Is that correct, or am I off on that?
Honestly, we want it everywhere.
Gotcha.
We just worked with a housing developer here in Florida, and we did an initial flatwork project. So you're thinking sidewalks, you're thinking driveways, then you're going to your concrete slabs for the foundation of the houses. You can go into exterior stuff, and then down here in South Florida, we have quite a bit of concrete tiles and rooftop pavers that you can put on there as well, which lasts up to 50 years, which could capture a lot of CO2 as you have much thinner concrete that has much more exposure and ability to actually capture and utilize that CO2.
So does what you're doing change the physical property of the concrete in any way? Does it, maybe make it stronger over time, or any change at all like that happen?
Exactly. So when we made this, the whole idea was, hey, how can we capture as much carbon as possible and then store it into concrete where it'll stay throughout the service life, and even at the end of its service life when you break it and grind it down. But what we found was that because the CO2 being captured is creating solid carbonates, filling in some micro cracks, some of the pores, it's actually making the concrete stronger. So we can actually increase the compressive strength, making it stronger, potentially last longer, and greener and more sustainable, and potentially able to mitigate and reduce the amount of maintenance. So it, as a byproduct of its capturing CO2, increases compressive strength.
This may seem like a silly question, but I'm going to answer it anyway, or ask it anyway. How do we know what you're doing works? I mean, how do you measure this? It seems like a tough thing to really measure or quantify.
Yeah. So there's a whole consortium. It's with NIST, and it's actually government, academia, industry. It's all of these different groups coming together to determine a one solution pathway for, okay, how do we quantify the amount of carbon being taken up? Because they also want to integrate that into what happens naturally into concrete. As look, we love cement and concrete manufacturers because we see ourselves having a great partnership and a relationship with them to help make their offerings more sustainable. They're doing the world a great service and giving it platform and giving it the foundation to actually live on, which is, all of our roads, all of our bridges, all of our homes, all the concrete that kind of don't see. We're all probably sitting on some concrete slab right now, effectively. So we've we've actually been working with universities like University of Miami. We initially were working with a couple of other universities when we were based up in Indianapolis. And we're also working with third-party labs that take the concrete and then they determine how much solid carbonates are built up in it compared to another piece of concrete without our technology, how much solid carbonates are built up in there over the same period of time. And then they just create whatever that delta is. How much more CO2 are we capturing and storing? So you're actually able to quantify those solid carbonates, i.e. the amount of CO2 that's been mineralized into the concrete. Now, the test methods are ASTM, but they're still challenging to really fully, everyone's wrapping their head around there and having a consensus on those.
You mentioned something about the, it can still capture concrete throughout a service life. Is there sort of like a saturation point where it's captured like the maximum amount of CO2 it can capture and then it's no longer, or is it continuously,
That's exactly right. So it's effectively like a sponge, and you can only put so much water until that sponge is overwhelmed. But we've received 2 grants from the Department of Defense in partnership with the U.S. Army Corps of Engineers to actually create feasibility reports, studies, R&D, and show them what we're doing compared to regular concrete. And let's say you have a block of regular concrete and there's a lot of carbonation on the top, but it doesn't allow any more CO2 to seep in any further, versus ours, which accelerates and increases that depth and increases the amount of carbonation. We may have gone 70% in and they only went 30% in. So if we go to 100, it's just going to stop. And then it's just, people are, well, what happens to the concrete then? Well, it serves its purpose. It's still concrete. Yeah.
So what is your go-to-market strategy? How are you bringing this technology to market? It seems like such a vast market out there. I'm just kind of curious how you tackle that.
Being really, really cognizant of the producers themselves. A producer that's been making concrete the same way for 20, 30, 50, 100 years doesn't want to do new stuff, right? So how do we integrate without, changing that process, with adding a whole bunch of new equipment? And then also, how do we make them the heroes? How do we help them from an adoption standpoint and benefit them? So we've seen our pathway is going the licensing path to actually license our formula to say, hey, take material A, which is our natural pozzolan that works this way and has this functionality, and material B, which is our catalyst, and add them to the concrete and their specific concrete at a certain dosage rate to create that carbon capturing effect. So we work with them hand in hand to say, okay, here's how you can make CO2 absorbing, CO2 capturing concrete. And then we in turn generate carbon credits every time they deploy a cubic yard of concrete or build a road or a bridge or something else. And then we share some of those proceeds as a revenue share for the carbon credits. And those carbon credits are great for 2 reasons. One, carbon credit signifies a ton of CO2 that's being captured, stored, or removed. And 2, it's a third-party quantification. And then you also then can monetize those and sell them to your big tech companies, governments, and financial institutions, investors, others that are buying carbon credits for whatever purposes they have, of reducing their carbon footprint or meeting ESG goals or investing.
So what do you figure ends up being the final cost to, however the concrete is being used?
So that's a really good question. Everybody wants to be green and sustainable, but guess what? No one wants to pay for it, right?
Absolutely, yeah.
And that was one of our biggest pieces with, all right, how do we work out these financials? How do we do the economics here where we can create either cost neutrality or a slight green premium, or maybe even a green or an actual financial return? So in some instances, we're able to, in for different products, maybe for a concrete product, we have some precast companies that work with us to create products. They can charge a green premium, or they can just charge the higher tier of pricing because it's green, it's sustainable, it's capturing CO2, it's actually making an impact. And for them, it's easier to kind of chew on a little bit of cost. But for the mass market and for the ready mix market, which is the majority of what's being deployed, we got to try to be really understanding and try to be really sensitive to those prices, at least today. There's a small percentage that will pay for more. So our main objective was, okay, well, how do we get these materials cheap enough And then how do we get a value proposition of a carbon credit that might be able to pay for those materials when we share those revenues to create the cost neutrality? Or there's some instances, to your question about how does it affect, the concrete? If it increases performance enough, you can actually take out some of the cement to create a cost savings that counteracts that additional cost. So those are kind of our pathways that we've found success with.
What are you seeing down the pike? I mean, I assume that you're seeing, eventually mandates and things are going to really support what you're doing and encourage it. Can you talk to us a little bit about, how you might see that playing out in future years? And maybe it's a crapshoot right now. I don't know. But what are your thoughts there?
What I'm seeing more from my side and my perspective is there's a huge customer-driven demand, right? Everyone wants more. And I'm sure you guys are seeing a little bit of this too, sustainable building materials, sustainable that, or more at least transparency around an EPD, an environmental product declaration. So as the competitor A has a sustainable solution that maybe is more marketable and giving them a leading edge for getting more business and winning more bids, competitor B is looking for another solution or that solution to also integrate. So we're seeing that competitive landscape actually creating some opportunity for more adoption. And then the carbon credit piece is big because you can quantifiably convey an environmental attribute of, hey, this concrete has 50% less CO2 than traditional concrete. Great. That's a good thing for everybody. So I think we're seeing that more than some of the potential, regulations and mandates. And once those regulations and mandates come in, and I think there's a little bit of a holdback for some of those regulations and mandates. And I've seen some data on this, that there's just not enough sustainable material to satisfy the whole of the concrete. Let's say everyone wanted to go to fly ash and slag. If the whole industry went to fly ash and slag to reduce 25% of their carbon footprint, we'd run out of fly ash and we'd run out of slag, potentially. So if that was the case, then you're mandating something that couldn't effectively be done. So you're kind of stuck between a rock and a hard place.
Gotcha.
So I think it's getting there, but the solutions need to scale up. And the other piece is, how does ASTM and these other specification agencies keep up with the rate of innovation? They're generally not great at that.
Yeah, you're right. That all is a process and takes time. Very interesting. This is just a fascinating field that you find yourself in, and you're really truly a pioneer, kind of figuring out all the angles of this. So I'm impressed. Well, you've also introduced a product recently called CoolCrete, which I understand is a concrete additive that helps to enhance solar reflectance and emittance. Sounds pretty fascinating. Tell us a little bit about that as well. And I assume that just kind of rides right along with the carbon capture.
You're right. In fact, it does. I would just call this the sister technology. I'm really excited about CoolCrete because this year, we've had the most 110 degrees plus days in recorded human history. We've also experienced the 2 hottest days in recorded human history as well, back in July, which, again, not good things. But as the world's getting hotter, how do we adopt to some of these things to help us live better lives and not have any issues with potentially heat-related illnesses and potentially worse? So CoolCrete was made as a potential solution to urban heat island effect, where when you have a very densely populated area with a lot of concrete building materials and it's a hot sunny day, those materials, not being organic materials, are actually absorbing this heat and then radiating it out. You're downtown where I am, close to downtown Miami, the city could be 10, 20 degrees hotter than ambient temperature in the middle of the city. So instead of a 100-degree hot, humid day, which sucks down here, by the way, if anyone's been in South Florida this time of the year, it could be 110, 120. And now that's not just uncomfortable, but it's potentially dangerous for us. So with CoolCrete, it's the first that we know of, cement replacement that replaces cement, lowering the carbon footprint 10, 20, 30, 40%. And then it gives the concrete the properties of being highly reflective to the sun and the UV coming down. So it doesn't absorb that heat. It doesn't radiate that heat. It's more effective at releasing that heat. And then the thermal emittance is how effectively does it minimize the amount of thermal conductivity, the amount of heat that's radiated into a building or a home? Let's say that this is on the outside of a building or a rooftop. Now, why is that important and why I'm really excited about it? Say you have a concrete roof in a commercial building, retail, or your house. If you have a darker roof, if you have a roof that absorbs a lot of heat and that transfers heat into your home, your air conditioning is turning on more frequently to counteract that heat, to keep it cooler. Not great for the AC, can definitely burn them out faster. On top of that, it's not great for your electric bill. So let's say you're increasing your electricity bill 10, 20, 30, 40% because of this heat. We could potentially be that solution to minimize that. Our results with one of our partners that's launching concrete, and that's why I'm talking about roofs, is a rooftop paver. And their results from the control without our technology to the paver with our technology is we're reducing about up to 10 to 11 degrees Celsius. You're almost 20 degrees Fahrenheit there. Every 1 degree Celsius that you could cool the interior of a building, you could reduce 3 to 5% of your electricity bill for cooling. And that's a pretty significant number. If that 10 degrees Celsius translated directly into 10 degrees Celsius of cooling in your building, 30 to 50% of your cooling bill would be reduced. That's a big number. And we can't make a claim because every roof, every insulation, every air conditioning, every property would be different. So you have to really see, what are the variables to determine how much potential energy reduction we can achieve. But the other big one is data centers. Data centers are super energy hungry. And if you keep those hot, they need to keep cooler. We can cool those down. We could put it on sidewalks. You could put it in around roads. It reduces the surface level temperature everywhere.
Well, I love that. And of course, in the metal roofing industry, we've worked with that for a number of years also in terms of coatings and things to make our products more reflective and emissive. We've worked with a lot with Florida Solar Energy Center there at UCF and Oak Ridge National Laboratory, Berkeley, Lawrence Berkeley National Lab as well. And a lot of great research being done into that area. Another area that we're seeing, and I'll just throw this out there, that a lot of work is being done is thermal breaks. And so, how can you include a thermal break in with a concrete product in order to help minimize that heat conduction as well? So cool stuff you're doing. Any thoughts on what might be next to your company for your company? You are what do I say here? You're just really pushing the envelope in so many areas.
Yeah, if my team would let me, I would create nonstop. I love coming up with these new inventions. I have a bunch of them, but, staying the path of keeping my blinders on so we can really create a significant positive environmental impact. And then we want to also inspire other companies and other founders, other entrepreneurs and other inventors to create more solutions similar to this. We had a town hall for our company yesterday, our first town hall for the year. And, I was saying at the end, look, if this was 10 years ago, Carbon Limit would probably be a charity because companies like this just weren't really a big deal back then. They weren't really, something that could create massive wealth or had huge valuations because what we were doing was too related on, either credits or other things to actually create value. So for us, for what's next, it's really creating these meaningful and these significant partnerships with the cement and concrete industry and the producers, and then also very large project developers, working with data centers, working with, and we're actually, still in process, but we've been in the Middle East quite a bit to work and try to find ways to partner with some of these giga projects, which we're currently engaging with. So just really excited about, where we can go with this technology, how we can help benefit not only ourselves and other concrete producers, but the society and the environment altogether. So we just look for these win-win-win partnerships, and we're really excited about it. More so that when we first started this company back in 2021, when we did our customer discovery, we were getting a bunch of yeah, like sounds cool. No one cared. Nobody cared. And then October was the shift where the Global Cement and Concrete Association said, okay, we're going to net zero and we're reducing 25% of carbon footprint by 2030. That's tomorrow in that industry. So all of a sudden, all those calls that were pretty cold called back up to us, and they're, hey, how about that stuff? So, the interest and the rate of adoption and just like where the world is today is really exciting for a company like ours. So it gives us a lot of validation. It gives the team a lot of motivation. And, we surround ourselves with such amazing human beings that are doing things that are helping not only, themselves, but their families, future generations in the world. So it's an exciting place for us.
Well, I love the fact that you're that entrepreneur that is always pushing and want to be there developing and leading the way. And I know sometimes I can try that in our company, and people are like, yeah, Todd, but we're carnivores. We like to eat. So we also have to be doing what we're doing to eat every day as well. But no, that's great stuff. And I think that's how the advancements take place is you got to have somebody that's driving those advancements and has that kind of curiosity to keep pushing ahead. So cool stuff. Well, Tim, it's been a great time talking to you. We're kind of close to wrapping up what we sort of call the business end of things. Is there anything we haven't covered today that you wanted to be sure to share with our audience?
No, I think this is a great conversation. Always like to share and always like to find what's relatable and what's good and what will help, provide more education about what we're doing, because we're solving an invisible problem, and, it's good to create that education. So I really enjoyed the conversation.
Great. Well, we have as well. Well, we'd like to invite you to do something we invite every guest to do, which is what we call our rapid fire questions. Tim, these are 7 questions. They're going to be out of the blue. You have no idea what we're going to ask. Are you up to the challenge of rapid fire?
I'm up challenges, yes.
Awesome. Well, we will alternate asking. Ethan, you want to ask question number 1?
Yeah, I can do the first one. What's a product or service that you've acquired recently that was like a real game changer for you?
Product or service that we've acquired as a company?
Or you personally, either way?
So I think it was our CRM that we acquired, because as we're formalizing and going from startup to growth scale-up mode, going from a very loosely held thing to like, hey, we can see how actually everything looks and where everything is. That was, I think, a huge boost and a huge kind of evolution for us. So it's called ClickUp, and it was helping us with this CRM and kind of connecting all of our teams. Once we're bigger than fitting around a small table, that was huge for us.
Gotcha. Yeah, that definitely makes a big difference.
You said that was QuickUp or ClickUp?
ClickUp.
Oh, okay.
ClickUp.
Cool.
Yeah. And those can be like integrated into Salesforce and other things that we're now looking at too. Yeah.
Well, shout out to ClickUp, and we'll include a lot of this stuff in the show notes as well for folks. So, question number 2: if I asked the elementary school Tim what he wanted to be when he grew up, what would he have told me?
I always wanted to be an inventor. I always invented things. I even made I made stuff when I was a kid. So I always dreamed of really inventing things and then traveling a lot. And I got both of those. But now I want to dial back that traveling a lot part, because I was traveling like every week and it was getting a little crazy. So I was right on cue.
That's awesome. Alrighty. Next question's kind of taking it the other direction, but what are your plans after you retire from working on, all these energy saving technologies and stuff? Are you going to kind of be a philanthropist still going after the same goals, or you think something totally different?
Right now, I want to be more on the philanthropist side, as well as on the creative platform for other technologies, other inventors, other potential businesses. I've been through a lot of different accelerators, from Techstars to Google's climate change accelerators, and a lot of these other accelerators where they help these businesses become formal businesses and actually go from, napkin sketch to actual business model and financial model. I'd love to help others to create these businesses. And also, selfishly, I want a platform that's got all the elements around it that could create all of my ideas and my inventions in rapid pace. So I would love to just continue to help other people achieve and realize their dreams and bring other things to the world. I call them society plus businesses that help society and that help the environment, something that's good for everybody.
Yeah, I love it.
Awesome. Question number 4. Well, you said you've traveled a lot and you enjoyed that, at least to a certain extent, but do you still have a bucket list vacation out there, something you'd like to do someday?
I have a lot. Yeah, a lot. I want to go all over Asia. I haven't had a chance to do so much that. Specific locations, going into like Thailand, Hong Kong. I'm I'm also more of even though I live in this South Florida paradise and tropical area, like I love it. Like I love heat. I know they have this new thing that's called coolcations where people are going to like Copenhagen and cooler places because it's getting hotter. I love the heat, so I love being in tropical places. I'm from Southern California originally, so I also like to have mountains in the background, which is the one thing that I'm missing here. So places like that, Bora Bora, cool spots like that I haven't been to yet that I look to go to.
Very nice.
This next question, this one's always an interesting one for me to hear what people's answers are. But if you could instantly master any skill, what would that skill be?
Speed reading.
That's a useful one, yeah.
I like that.
Yeah, I love reading. And when I say reading, I mean typically listening to books because I just don't have enough time to read. I listen to at least a book a week, sometimes two. But if I could speed read as well, because I can speed listen right now really well. But the speed reading I want to get down.
Well, that said, I'm going to change what I planned for the next question. What is a good book you've read or listened to recently that you would recommend to our audience?
So I gave this out as our company Bible, a couple years back. Was Buddha and the Badass by Vishen Lakhiani. He's the founder of Mind Valley, and they have these really cool courses on different parts of life and mastery. And there's actually one by Jim Quick, which is speed reading, so I can get into that one too. So that one I think is usually good for a general audience because it can apply to everyone. It's not a business book, and it's called Buddha. It is, and it isn't a business book, and it's kind of a personal development book as well. And it's Buddha and the Badass, but it's nothing to do with religion. So a really cool one that I'm always recommending on a generalized basis. Some of the books that I listen to are super crazy, and unless you're ready for it, you won't get it.
Well, if you're at that kind of volume of reading and listening to books, I understand that too. Good stuff.
Yeah.
Well, Buddha and the Badass. I think I've heard of that, but I'm going to check it out. Thank you.
All right, last question. What do you want to be remembered for at the end of your days?
How much impact and how many people I've helped. I love to do things that I can, help create with others and help others become the best version of themselves. And I just love having these great mutually beneficial relationships. And, sometimes it's more fulfilling just to give than it is to get. So really that impact and then how many people I've helped.
Good answer. Well, Tim, this has been fantastic. Thank you again. For folks who would like to get in touch with you or perhaps learn more about Carbon Limit or CoolCrete, how can they do that? Give us some websites or whatever works.
Sure. So I'm the worst social media person, and maybe I shouldn't create a self-fulfilling prophecy on that one, but I am sometimes on LinkedIn. So if you want to try to reach me on LinkedIn, you can certainly find me, Tim Sperry, Carbon Limit. And there's also carbonlimit.com. And with carbonlimit.com, you can look at Capture Crete, our CO2 capturing concrete, as well as CoolCrete. And that's generally the best way to catch me or to learn a little bit more about us.
Very good. Well, so our audience knows, I think we were all successful working in our challenge words. Ethan, your word was?
Mine was philanthropist.
You got it in there in your question. Good job.
I did. I modified one of the questions. That's usually my trick if I can't find another spot. So.
And Tim, your word was?
Zoology, and I got it in like my first little spit.
So what was it like taking a zoology class? Did you enjoy that?
I actually did take the class. I didn't just make that up to fit the word in there, but yeah, it was good. It was my first year at University of Wisconsin-Madison, and it was interesting. So I really enjoyed the college experience at that point. So I had some really interesting classes. The one that always sticks out to me is called The Brain Demystified. And the first day of class, they had a 3D projector that they had a real live human brain on, and they cut it up. And I was like, wow, this is cool. It was the first day of class. So, and I think that was right after my zoology class. So it's why it stuck out so much.
Good stuff. Well, the word I had was carnivore, which I kind of worked in awkwardly, but I got it in there. So
it worked, yeah.
Well, thank you again, Tim. This has been great. Thank you for being on the show.
Yeah, it's been a pleasure. Really great to be on with you guys.
And thank you to our audience for tuning into this very special episode of Construction Disruption with Tim Sperry of Carbon Limit. Please watch for future episodes of our podcast. We always have great guests. Don't forget to leave a review or give us a thumbs up, whatever is appropriate. Until the next time we're together, though, keep on disrupting and challenging, looking for better ways of doing things. And don't forget to have a positive impact on everyone that you encounter. So God bless and take care. This is Isaiah Industries signing off until the next episode of Construction Disruption.
This podcast is produced by Isaiah Industries, manufacturer of specialty metal roofing and other building products.